Good morning. Good morning, everyone. Thank you and welcome for being here with us today. Today, we are talking about building out data pipelines and orchestrating them. We'll touch bases on the details of what that really means. Um, I really thank you for being here with us today. If you take a look at the chat, I pasted a couple of links in there. One is for the GitHub project that you can follow with us as we get deeper into the presentation, and you can find other information, additional information. Also, there's a book that gives you more details about everything that we're covering today, in addition to other phases of a data engineering process. So thank you for being here with us. My name is Oscar Garcia. I'm a data engineer, principal engineer. Just like many of you, I do software development, data engineering solutions, cloud solutions. So I'm really happy that you're here, that you're able to join me today. So let's get going and understand what are data pipelines and what do we mean by orchestration. To start with, let's talk about data engineering overview. So data engineering is really a process that involves several steps, as you see in the graph to your right. And basically, today we are talking about data pipelines and orchestration. And the topics that we are going to address today really are about understanding what a data pipeline is. What are the implementation options that we can use to build those pipelines? Uh, kind of cloud resources that we need for those pipelines to run on, um, and how do we build a code-centric flow or data pipeline, right? So there are options with no code as well as code-centric, where where it's just basically we do the implementation through code, right? And also the importance of deploying the solutions with Docker, and importantly monitors and operations, right? Everything we build here is has to be with operations in mind, with the possibility and the ability to instrument the solutions, so the operations team can actually monitor and manage that solution for us. As usual, this project, you can follow this on GitHub. There is a link right there at the bottom of the slide. Also, I pasted that link on the chat. Please follow that project. We continue to grow it. A lot of the stuff, information in that project, it's an ongoing work as data engineering practices and technologies advance. We update that information so we keep it up to date with the latest trends. There's also a book associated with all this information that you can use for reference. But please give it a start, take a look, follow it, start the project so we actually rank somewhat good with GitHub, with our friends at GitHub. And that gives us credit to basically continue to support this effort. But let's continue on to the topics. And as usual, as well, there's a lot of code to review on this session. And don't worry, if we go too fast, you have all the source code in GitHub. All right, let's understand pipelines, right? What do we mean by that? Uh, in short, a data pipeline is just really a series of connected tasks that basically do like an ETL or ELT process, really. So what this means is really extracting the data from some source, transforming it and loading it into a target data storage, right? Or in some instances, extracting it, loading it, and then transforming it. So it really depends on your architecture, right? Even though this sounds very similar, there's a lot of difference. I can tell you pretty quickly that ETL, usually the transformation is mostly done on the code itself through VMs. And the with ELT, most of the approach there is to do it on the data warehouse, for example, using the power of the data warehouse engine and SQL to be able to do transformation, which seems to be in many cases a lot faster. Um, Foundational areas about data pipelines really is the how to ingest and transform the data. I'll talk about, do we do code-centric versus low-code options? Do we do what is the orchestration of this, right? What is it? does it really mean, and the cloud resources, and implementing the flows and the tasks and the components. We'll touch in detail about that. Deploying the solution and the monitors and operations, right, as we discussed. So that all involves the data pipeline. Data pipeline is not just the code, but is the entire solution. Otherwise, you have an incomplete data pipeline, right? What is the data ingestion and transformation? This is really when you process the data from some source, whether it's some other SQL databases, MySQL, or APIs, or some CSV files that a lot of the sites will post somewhere for us to download and process, or it can even be a real-time data feed. And we'll talk about that more in detail. There's also a nice presentation on real-time data integration, which involves Spark and Kafka. If you're interested on that topics, we'll have one in the near future. But the key areas really here is to identify those methods, right? What is the integration point, right? Is it a CSV file? In our case here, for this sample, for this presentation, we'll integrate it with the MTA system, which is the subway system from New York. And they expose CSV files that we can download and process. What is the process, right? Is it a batch or streaming process? And that really depends on the data source, right? And the difference between that is a batch process really done with when you have a data source that provides a batch update, or if it is real-time update, is some kind of streaming data source, socket, WebSocket data source, a streaming data, and you basically connect to it via events or messages, depending on the architecture. But definitely areas of cleaning the data and making the data with a standard format to ensure the quality and consistency of our data, right? So, for example, you may have some records that are incomplete with null values, data that's junk data. So there's a process of basically cleaning this up and taking on real high quality data for our process. And also there's the alternatives of actually in this data with some context or values that are important or relevant. But this is all part of that data pipeline process where you take care of doing all these things and basically formatting into the required data models for analysis. The end goal of all this is to create a data pipeline for a data analysis process, what that really means is putting that information from into a data lake so it can be processed downstream into a data warehouse, where you can tap into it and do data analysis and visualization through tools like Power BI, Looker Studios, and some maybe JavaScript dashboards and visualizations. Implementation options, right? So like anything, once you start building out your data pipeline, really depending on your team, depending on the I guess the company, the maturity level of the company, you can basically take on a coding approach, a code-centric approach, using languages like Python, SQL, or maybe other languages like even C#, .NET, or you can also go and take the approach of a low-code tool with zero or some code snippets to process the data. So a low-code tool basically is mostly a diagram tool where you can actually draw data pipelines, and then you can, it's something that is very specific to you. You can drop a snippet to do that particular transformation or process that data, and there you go, and you basically design a data pipeline. The code-centric basically is where you code it yourself, right? You type in you write the Python code, the SQL code, right? And it's heavy on the programming. Our approach today is Python, right? We are using Python to build our pipelines, and we're using cloud resources and tools to manage the orchestration of that pipeline. Welcome to everyone, those that have joined us a little bit once we started. Thank you for being here. Just wanted to welcome you again. So my name is Oscar Garcia, by the way, if you didn't get to catch my name before. Let's continue. So what is pipeline orchestration, right? So we talked about pipeline, and you'll hear the terms like orchestration, data pipeline and data orchestration and so on, right? What does that really mean, right? So the orchestration is really now is the automation and the management of the data pipeline. So once you have your solution, right, you build your coded or your code-centric pipeline or your low-code pipeline. You need to understand how it's running, how healthy it is, what are the failure points, what are the errors, how fast, what is the performance of it. So for that, you need some orchestration tool to help you do that, right? So it will help you. Orchestration tool will help you do monitors and dashboards, and it will help with the scheduling of the tasks and the recovering of the tasks and the notification, right, when there are errors. Orchestration engines are also useful for deployments and components, and we'll touch that more in detail of that a little bit later. But some of the popular orchestration tools are like Apache Airflow, right? It's very, very common. That requires a lot of Python code to be able to do some of the complex pipelines. Apache Spark, also another great platform that enables us to do large-scale batch and streaming data processing, right? And we can use Python for that. We can use uh, um, different languages to support a series of languages that you can use for that, to be able to run it, like Scala as well. So you can use a lot of languages for that. So it has a very good support. Also, there's libraries like Prefect that provide you a code-centric library support where you can actually instrument your code to be able to integrate to a cloud platform and be able to kind of build out the logs, the visualizations and the monitors and the alerts within the pipeline. So the whole idea is, if the pipeline is running, when did it start, when did it end, are there any errors, and you can actually see the telemetry coming out of that pipeline. And of course, if you choose a cloud-based service, turnkey solution like maybe Data Factory or GCP Cloud Data Flow, I mean, they provide the tooling behind the scenes to be able to give you the orchestration. They provide scheduling, they provide monitors, they provide all that. So the key here is not to focus on one product or one approach, but to understand the need, the requirements, right? What is it that we need to be able to support orchestration in our data pipeline? And of course, we'll talk about deployments with Docker and integration with GitHub. But once we know and we have the approach defined, we understand how we're going to build this out, we need to start thinking about what cloud resources we need. For a code-centric pipeline where we need to actually deploy our code, our solutions, we need to run this on VMs, right? So that's basically how things would run on the cloud. We stand up a VM, and we build our code with Docker. We deploy it there, and it runs, and it just basically we keep our pipeline running all the time on the VMs, right? And we can scale those VMs if we need resources. We can scale them horizontally to be able to get more instances and sort of distribute some of the pipeline work, so it's not running just on one. So definitely, so where is this data going to go? So it really also depends on the architecture. Most of the time, you will do a data lake integration, right? So once you start downloading all this data, which will have many different formats, CSV, XML, JSON, unstructured data, text files that you need to parse, for example, then most of the time you will build the data lake. So that will be our staging area for all this data, raw data that we download, so we can later on apply a transformation in data processing task to now determine if we're going to put it on a data warehouse or not. But that's downstream. So right now our focus is from our compute engine into our data lake. And that's the approach, right? And the same for low-code tools. Usually what you see here is what a low-code tool would definitely have behind the scenes. That's why it's a turnkey solution. They build out their own resources, right? So they build out their own VMs and storage and things of that nature. So, but behind the scenes, it's really the same thing. It's really not magic behind the scenes for those low-code tools. They build out what we often do with a code approach. Okay, so Um, Implementing code-centric flows, right? So what do we mean by flow? So we're talking about data pipeline. Now, what do you mean with a flow, right? And so what happens is the data pipeline is the entire concept, right? So now when we start going into the implementation, we build out flows, right? And the flows is really the sequence of steps that we're gonna do, right? So for example, it will be call this API, download the file, write the file to this, process the file, right? And those single steps of download, save to this, process is all a task. So a flow will coordinate this series of steps so you're able to integrate into the data pipeline, right? And as you mature your process, right, and you build out your tasks and your flows, you're gonna identify cross-cutting concerns and tasks that are done very frequently or that may need high security for its execution, right? And for those, then you probably start building out components, right? And those components really will be sort of libraries that are going to be stored on some cloud resource that you can actually reuse. So basically, if we need security, right, which is important, when you run from a VM, you probably will need to have access to a data lake or to a data warehouse, or you need to do some specific tasks, right? So you will build out components, and these components will handle the logic of authenticating and authorizing your code, your pipeline into a particular resource, so you're able to do something, right? So this approach enables us to now, as we build common components, to build out just the specific flows and specific tasks that are unique for that particular effort that we're trying to do. What you see here on the screen really is just part of that orchestration effort, which is, hey, we're building out this flow, and as we execute this flow and task, let's log it, right? Let's log the telemetry, and let's look at the execution, what it's doing, how long does it take, is it failing? So this really is a dashboard that's tracking this as our flow executes, our pipeline executes. Part of the orchestration is to send that telemetry data, capture it, put it on the monitors, right? So this is key. Kind of be able to understand that you have that support is very important for operations. So now that we know that we are running our flows, we have our code running, and we need to deploy it, we need to start thinking how we're going to do that, right? We understand that this is probably going to run on a VM. So how do we do that? So we have our code on GitHub, and how do we build this? How do we get this code into that VM? So usually for that, we build out Docker containers, right? Which is really a self-contained environment with all the dependencies, right? So a container will enable us to not just copy our source code into it, but also include dependencies like maybe Python, the particular version of Python that we need, the particular dependencies that we need, all right? And then we can actually create this image, this Docker image, and push it to a Docker Hub, which is like a repo for images that we can then later on download into our VMs, and it create another node for our data pipeline. So if you can imagine, we provision through Terraform a new VM, and then in part of that deployment process, CI/CD process, we can say, go get this Docker Hub image, download it, and now we have a new node that is running our pipeline in a new VM. So this is kind of like the very important way of doing a sort of a native cloud data pipeline implementation, right? So I previously said monitor and operations. So as we build out our data pipeline, it's important to have the telemetry tracking, right? So tracing. So we understand that as our code is executing, we're tracking activities. We know when it started, when it completed, errors, and so on. So this is very important to be able to provision a resource, regardless of the tool, regardless of the data cloud providers. Just kind of important to understand that these are requirements, right? We need to understand that the engine or the cloud provider we're connecting with or using has these tools for us to be able to monitor our our code, the process of our data pipeline, right? So we need to understand the monitors, good dashboards that will give us some KPIs to be able to track performance. And if you're measuring data, you may be measuring the amount of data you're transferring and so on, right? And definitely notifications to support any errors, to support failures on the pipeline, to be able to notify the support team, hey, something is failing, please help us out, give us the report so the developers can go ahead and make the updates to the code and fix any issues. Or if it is an operational issue like an outage and some resource that's failing for some reason, so they can understand what's going on with that, and they take measures against it. So in short, data pipeline, it's just really the entire process, right? It's really not just the code itself, but it's really the entire process to be able to do data ingestion and transformation. The approach, if it's code or low code, orchestration, which is key. The cloud resources we need to be able to support it, and the coding and the deployment practices for us to be able to support the monitoring and the operations of our data pipeline, which are very important for this process. This is a summary of all the technologies that we discussed right now. We're gonna now really take a look at some code so we understand really what does it look like now, right? So let's take a look at that. So let's switch now to I'm going to switch now to GitHub. As I pointed out before, there's a GitHub repo. It's on the chat. You can take a look at the chat to get the URL, or you can take a screenshot of what you see in front of you. There's also the links in there. But the GitHub repo is right here. This is where we have all the coding here. And what we're talking about today is we're talking about the step 3, which is data pipelines and orchestration. Please, as you look at this project, give it a star. Keep joining us, keep following this. We continue to grow it. Just a quick summary of this project. Really, this is a data engineering project integration with subway system for the city of New York. And we do a lot of stuff here to be able to just sort of share the information of how do we do this data engineering practices, right, with the tooling and all that. So you can read about it, you can get an idea what the problem statement is and why are we doing this, and the end goal to basically get these files to be able to visualize all this information as you see here. That's really the end goal. But let's take a look really quick. As you look at this project, you will see the source code here, depending on the phase of the project. For example, step 3 is orchestration, data pipeline. What you will do here is, as you click through, you will see the source code here. You will see flow, you will see deployments, you will see code blocks, which are the components, some of the Docker files, so the Jupyter notebooks to be able to sort of play with the data, model the data, and understand the data. And it will give you the entire instruction on how to set up your environment, how to install dependencies, and how to configure everything. So we'll get back to this at the end, but now let's dive into the source code itself. The source code will be under the flows, the deployments, and blocks. And you will see all the files in here. I'm going to switch to Visual Studio Code so we're able to interact a little bit with it. So that should be loading. Okay, so this is the same README file that I was just browsing through right now through GitHub. It's really here in this project as well. But opening up the file under the flows directory, you have this main pipeline that really what it does, it has, if you take a look at the code, right, it has an entry point. And basically what it's doing is really parsing out the parameters, the arguments that are sent to it to get the year, the month, and the day. So for our data pipeline here is that we need to go and download a file that has a particular path, right? And that path is really a structure like a month, a year, month, and day. And so we're requesting that information to be able to say, okay, so the automation. So if you think about it, the instrumentation, the automation of this as we do the orchestration, it will be able to build out this dates and pass this and call this and do the automation to call this code. So now, but the entry point is just really for when you run this on its own. What's important here is to notice that I could use this to run it locally, but you will notice that there's going to be a main flow here, right? So keep track of that. That's very important. But what will happen here is that when we call this, we can basically just use this code on line 223, and I think this is big enough for you to see it clearly, right? This is how you can call this manually, right? And it will just basically, what it will do, it will just go through the pipeline and process the file, download the file, and process it into our data lake. So to quickly show you that, you could go ahead and query our data storage through a command through the CLI. Right, it's a little slow to go through the command line right now, but you could just type those commands, and basically it will just query and show you all the data files that exist there, right? So you'll notice here is that we have a file. The latest file that we downloaded is for January, right? It's for January. So, and I'll flip to what the data storage looks like on the browser really quick, but just to show you and illustrate this to you, right? If you go to Google Cloud for this is really what bucket looks like. And in the bucket, you will see that we have a file from January the 6th, right? That's a file that we downloaded for January the 6th. But so the requirements for this integration is that they have a batch update of every week, for example. So the next batch or the next file is available on the 7th, on the 13th, I'm sorry, right? So it's every 7 days on a Saturday. So what that means is if we flip back to the code and if you look at this, so it will be the 13th. So that will be a Saturday, January the 13th, that it will query, it will record. And the way you can run it to test it, right? To unit test this, and to kind of for us to get an idea is just to go ahead and type this in the command line, right? And then just let it process, right? So, and of course, what you need to do is you need to be under the flows folder. So you need to go on there, step 3, right, and go into flows, right, and there you will find a file, and then you can just basically run that file. And what it will do, it will go ahead and just execute the file. So while this is running, because it's alive, right, it's going to run, it's going to take its time, it's going to do whatever it needs to do. Let's go look at the code. So essentially what I did is I called that, I'm passing these arguments. And then what I'm saying is I'm validating and it's processing now. So if you notice, it's just creating a bunch of telemetry data now. And it's pumping something and it's giving it some unique names for us to. And that's the telemetry data to log what's happening, right? It's finding the files, downloading the files. So the way it did, it went and it executed this main flow. Now, this main flow is decorated in such a way that gives us what we call a function decorator or attributes that act as a filter or as a callable instance of a function to be able to actually when I call main flow, it intercepts that call, it puts some telemetry, sends some telemetry data to the cloud, and then calls the main flow, passes all the parameters to the main flow, so main flow can do its work. But what you will notice is right now it's just downloading something, right? You can see the activity behind the scenes. It's just downloading some data, but the code is simple, right? It's just saying, hey, if I don't have the year, let me generate a date on the fly. And if I do have a date, let me validate that these dates are valid. So some of these rules will be to say, validate that it is a Saturday, because that's the requirement, right? If it is a Saturday, make sure if the day is a Saturday, it's good. Otherwise, we know we're not going to find a file for that date, right? So it does that as a task. So these things, if we take a look at what the task looks like, right? So what happens here is that this one is also decorated as a task. And it's the same thing, right? The approach is that we will be able to track this task we're going to be able to log that that the flow call list to validate it, and this might fail. If the data is incorrect, it's probably going to fail if it's a bad day, and we'll be able to track it. And then, as it is an automated process, there may be something wrong with the automation configuration, and the operator will be able to report, hey, we're sending the wrong dates to the data pipeline. A developer or someone needs to correct that. Okay, so we continue with the flow, and the flow just basically goes and it says, hey, I think everything looks good. Let me go ahead and call this new flow called a download from web to local. So basically what it will do is download the file, get it into some a staging area, and then it's going to write it and upload it to GCS, which is Google Cloud Storage, right? So, and what you will just basically see as you download the file and we write to GCS, let's take a look at that one because that one's important, right? What it will do here, this is key, right? It's another task. It's decorated with that task attribute. And then what we're saying here is that we're saying, hey, let me get a block name for this, right? And then we're defining the path of the file, and then we're using something called GCS bucket load with a block name, and we're uploading the file. What that is really, in reality, that is a component. So we're actually saying, hey, I have a code block or a component. I want to get that, and I want to execute that to be able to do my bucket load. So basically, that handles that continuous task of saying, handle my security, handle the upload process, because I'm going to be in this in many pipelines, not just this one, right? So let me reuse this code to be able to do that. So that's important to do that, and also decorate this function so you know that is that's a step in that pipeline, so you're able to track what is going on. And same thing with write local. Really, it's just really it's another task that we call is really saying here, hey, look, go get this file, do some operations on it, and just go ahead and do the download, right? So do the download, do the file compression. You can convert that to a Parquet file if you need to, depending on your requirements. But you just kind of process that data, right? So that's how you start building out this data pipeline in small chunks of code, and you'll be able to basically create that data flow with all this code, right? So you can kind of see here that ETL web to local is really saying here, go ahead and using pandas. If you're, I hope you're familiar with pandas, which is a Python library. Go ahead and download this file by use an iterator and use a chunk size of 5K to be able to not just download in one chunk, but actually in one whole file, but to download it in segments, so that to address any kind of timeout issues, and for the process to actually have the ability to just kind of download the information in chunks, in data chunks, which makes it more effective. Okay, so that's basically what the data pipeline for this is, right? Of course, this is a very simple implementation of a URL. So basically, you will read the documentation and you will see basically the URL is like line 212. That's the URL that gets built, gets constructed, and then you'll be able to see that it gets that file, downloads that file, and it writes it to storage. So if we now look at this one, this ended, right? So it says that flow run Hungary, okay, API, finish, and it completed. And we can see all the tasks that it executed, right? And we can see the telemetry, right? We can see all the telemetry that was actually issuing for us. And what you could do now is here, come back to this terminal, and we can just basically query that. But of course, the CLI takes a little while, right? It's a little slow going over the wire into Google Cloud, and it's actually querying the metadata for the Google storage and be able to get the new files that exist, right? So before we had 13 objects, right? That was what it found before. Now we should have 14 objects because it added, if you notice here in the terminal here at the bottom, I'm highlighting it, it had 13. So now it should be 14 because it's going to find the additional file, right? So it takes a little while. The CLIs are a little slow here. But what you could do also is you could go to the cloud, the browser, and just refresh that page, and you will see that a new file gets created, and the file is there in a compressed format, right? And the whole idea of the compressed format also is because we need to be able to we want to be able to have some kind of storage performance improvements, right? And we want to be able to do that. So as we can see, we downloaded a file for the 13th of January today, March 6th. So we have a new object here, and we're able to download that file. But that file is just downloaded there, right? Is what happens to it now, right? It's just on the data lake. Is it available to our data warehouse? And this is a whole different conversation. How do we get it to data warehouse? But what will happen is really quick. The data warehouse is integrates with the data lake and can see files that are there, right? So if we were to query the data warehouse, by the way, this is BigQuery. If we query this, what we will notice is that before we had 22 account of 22 records for anything over older than or more recent than January the 7th. If we run this again, what it will do, it will just go and basically query anything that is on the data lake, and it will be able to open up the files like they were tables, right? And be able to now show us that we jumped to 215,000 rows, right? So what that means is that the file is completely safe, the format is good, the compression worked, and BigQuery is able to reach out to the data lake, get that file, read the records. But at this point, right, there's an additional step for this. At this point, we're using this as an external table. There's a data process to get that and break down the information into dimension tables, into fact tables, and all that. That's a whole new subject. What we call is that's really the data modeling and the data warehouse project, which you can actually also take a look at here on step 4. And we're going to be having another presentation on that later this month. Okay. But continuing with this, right? So we saw the data pipeline, we saw the integration, we saw in the code that already CLI came back, not yet, still hanging in there. So if we go back to the project, we can see that we had this, we finally came up with the 14 objects. You can see that that's our main data flow, our data pipeline, if you will. And we took advantage of data blocks or components in deployment definitions, right? So a data block, like we saw it, right? Is that GCS or storage upload, file upload, right? So the first thing is we need to log into that Google Cloud or whatever cloud provider instance. So we create a code block for security, right? And this code block for security is essentially what it does. It actually goes and it says, hey, let me read a sort of security file, package this and save it as a code block into my into my cloud provider, right? So what it does is a component for security that we can reuse, and we can now see the logging information, right? The secrets and the keys and things like that. It's like a vault approach. If you're familiar with that, it's really a vault where we're saying, let's put this into a vault so other components can use it. So when we have the storage component using it, right? So this is a storage component. It would just really say, look, okay, let me get the security block, the account block or component. Let me get the bucket name, and let me create another component to be able to manage everything that has to do with uploading files to a Google storage bucket, right? So this way, your code, your pipeline, your flows and tasks are simple, because now you only worry about the coordination of the flow as opposed to common concerns like writing security, writing file uploads to Google storage, and so on. So that's key. All right. So now we have the code and all that. How do we build this out? So now we're ready to go. We test it locally. Things are flowing. Data warehouse can see it. We know it's good. Okay, so let's go ahead and do deployments now. So let's take a look at what that means. So we got to build a Docker file here. So if you're not familiar with Docker, really all it is a Docker file that we define. We add the dependencies. So in this case, we're adding all the Prefect dependencies. If you look at line 1, We adding something called Docker requirement text, which is really is a list of dependencies, and you can take a look here, Docker requirements, right? And we're saying, hey, we want to get the pandas dependencies, a prefect, cloud storage, and so on, right? So you list the dependencies, and the whole purpose of that is that as we built our Docker container, we're able to say, copy this Docker into the container definition, run the pip install to install all those dependencies into that isolated environment. This is now within the container. And then we make directories for our code, and then we copy our flows into that folder, right? So as we copy this, the code, now everything is in the container. We need to build a container, right? And what you will have here, if you follow the instruction on GitHub, you will have a process definition there, how to do that, right? How to do the scheduling. You can take a look at this to see how Prefect does all the scheduling, and we'll take a look at that before we run out of time. But this is weekly scheduling and all those things. He will take you through all that. But since we're talking about Docker, right, he tells you how to install Docker, how to do pip install requirements for your environment, for you to run this locally. Of course, you need to have your own GCP credentials and things of that nature. Your own Prefect account, you need to issue all those, but it will give you all those instructions, right? All the command lines that you can say for Prefect to do the, for example, the flow runs and all those things. So you could just basically run through CLI. We could just go and do things like Prefect. Let me see if I have it in the cache. Yeah, so we can see the Prefect blocks, and we can query. No, so it's Prefect. Okay, just take a look at the command. I probably have a typo in it. Prefect block less. Yes, so that one had a typo. So this one can say, hey, look, query all the blocks that we have defined in our cloud environment. And it was of course, all of this is on the cloud, right? It will tell you, I have a Docker container, I have an email block, a GCP credential, and so on. So these are basically, this is sort of a vault where you have all this code that you can reuse. And of course, you can continue to look at all this to be able to do everything. And of course, you can also do this with GitHub, right? So you can also configure GitHub to be able to do some of the stuff, so you can automate the deployment of all of this. But quickly going back to the browser now, is that we have to understand that when you have your Prefect account, then you will have your dashboards here, right? And your dashboard, as part of that orchestration and operations, is going to help you look at what's going on, right? And when you notice, all of this information is here because all we did is decorated our pipeline, right? We decorated our flows, we decorated our tasks, and all that telemetry data gets captured automatically for us, right? So of course, we can look at the flow runs, and if you remember through Visual Studio Code, we saw that all that telemetry noise, right? So basically what you will see is that there was a batch, a flow execution here, and you can see the amount of tasks that were executed. So for example, this OK API that we notice on the console, we can see, right? We can see that we validated the task, we got the file days, we write to the storage, and we can see, we can visualize how long did it take, and we can see the steps that it took, right? And we can monitor if something failed. And if we need to drill down into a task, like we saw that there was a subtask to download the file, we can see that this will give us all this telemetry of, I did this and I did that, right? So you can see all the logging that is associated with that telemetry, right? So imagine if you have a more complex data flow where you have all kinds of conditions and all kinds of branches where you go to. All right, so please go back to the project, give it a star, review, read this, get familiar with it, follow us for the next presentation. I think we ran out of time. We hit right 12:45, right on the mark. If you have any questions, this is the time for Q&A, please. But going back to this, please go back to the presentation, take a look at that. I mean, the repo, take a look at the repo, take a look at the book if you're interested. It has more details about everything that I talk about. But also give us a star on the GitHub repo, please. I'll be building out the video presentation, will be uploaded to YouTube, and I'll share that with you, and I'll share also all the video, all the presentation content with you. So if you have any questions, if you don't have any questions, I definitely want to thank you for being here with us. Thank you for spending the time. I know is it's in the middle of the day and you probably need to go back to work. I appreciate it. Please let me know, give it a star, send me any kind of message you want to through Twitter, GitHub, and keep following us so we can continue to grow this. Okay. If no questions, guys, I really appreciate it. Thank you for participating with me today, for being here with me today. And I'll send you an email with additional information. Keep following the group for new presentations. We have another one upcoming next week, which is very interesting. Take a look and join us. Thank you, everyone, and have a wonderful day. Thanks a lot.